So this is the 500-gallon machine. We also have made 1,500-gallon machines and 2,000-gallon machines, all the way up to 300 horsepower. This is 75 horsepower machine. The disc attrition mill is also 75 horsepower. Here you can see the discharge from the super blender. That's a 75 horsepower drive motor, by the way. And this is a 3-inch discharge that goes through a gasoline pump for our test purposes. The pump transfers it into the back of the disc attrition mill, where it receives a fine grind. It discharges from there, goes through a T. We can branch off of that T and go to a sample box right there with a screen in it. Or we can recirculate back into the tank. And that's just a little test apparatus that we set up for the purpose of grinding things up and testing for the customer. This disc attrition mill, inside you can locate a number of different stator rotor configurations to do most anything you need to do. Configure it as a extremely fine grinder. It grinds rock and sand to 100 micron particle size. It just all depends on the application. We configure each one for the customer's needs. This is the hydraulic power unit that actually motivates the hydraulic cylinder on top of that machine. That cylinder is actually what sets the gap between the stator and rotor, so that you can compensate for wear to keep the machine operating at optimal conditions at all time. Plus, the same system is used to circulate barrier fluid through the mechanical seal, through the filter, through the cooler and back, and it's used to actually pressurize the mechanical seal as well. The same is true for the super blender. It has a hydraulic power unit that motivates the hydraulic cylinder that positions the rotor. That's the cylinder right there. That determines the gap between the rotor and the extraction plate inside, and then that's adjustable so you can compensate for wear. And also this circulates the barrier fluid through the mechanical seal, through the cooler and filter and so forth. This is the view of the rotor inside the super blender. Right now this rotor is set at the maximum gap between the extraction plate with the holes in it and the rotor shoes, which are replaceable. That gap can be adjusted from 1 inch all the way down to 0.010 of an inch from that plate. And it's also used to compensate from wear of those shoes. This rotor operates equally well in both directions of rotation, so that the operator has the opportunity to wear both sides of the rotor flights before it becomes necessary to take the shoes out and have them sharpened or reground. This is a view of the disc attrition mill with the door opened up, and this has intermeshing teeth mounted in it right now that do a medium grind to the material. Today we're going to run the machine and process some typical biofuels materials. This is hay that will simulate switchgrass. This is just chips of rubber, long slivers and chips. wood chips. And more wood chips. This is the kind of stuff we're just going to throw in all at once and see what kind of particle size we can produce and catch on this screen. Yeah, just dump it. Okay. That's hay, wood chips, and rubber chips. That's the fine grinding stator. That's the fine grinding rotor. Okay.